Hi everyone, here's the promised solutions video for our practice test. Alright, solve the systems algebraically. I think on this one, I think most of you used substitution. I'm looking at this. If I add these two together, I can eliminate the y's right away. But I'll use substitution on this. I'm going to solve negative 2x plus y equals 5. And I have y equals 2x plus 5. I just rewrote that. Now I'm going to substitute for y. I'm going to substitute 2x plus 5 right here. So x squared plus 3x minus 2x plus 5 is equal to 1, which is x squared plus 3x minus 2x minus 5 equals 1. Distribute that minus, which is x squared, and I'm going to subtract 1 from both sides also, so I'll have 0 there. X squared, 3x plus minus 2x is x. Negative 5 minus 1 is negative 6 is equal to 0. 1 minus 1 is 0. That factors, and I need a 3 and a 2, and I need the 3 to be the positive one, the 2 to be the negative one. So x equals negative 3. X equals 2, and then we just plug that in. I'm going to use where we solved for y. You could plug it in here or here, and this would probably be easier, but I'm going to even use this one where we got y by itself. Y equals 2 times negative 3 plus 5, which is negative 6 plus 5, which is negative 1. So one of our ordered pairs is negative 3, negative 1. And then substitute the 2 in, so y equals 2 times 2 plus 5. That's 4 plus 5, which is 9. So my other solution is 2, 9. And this one I think I will use elimination. This is positive, this is negative, so I'm going to multiply this equation by 2. And that gives me 2 over x plus 4 over y equals 10. This one gives me 3 over x minus 4 over y equals negative 5. I didn't do anything to that because I've got the opposites that I need after multiplying by 2. So 2 over x plus 3 over x is 5 over x. Those cancel. 10 minus 5 is 5. So what I'm going to do is I'm going to multiply both sides by x because I don't like that x being in the denominator. So now I've got 5 equals 5x. I could have just looked at it and said, well, 5 divided by what number is equal to 5? And that answer is 1. So x equals 1. And that's the only value for x. Here remember we had a quadratic. We got 2 answers for x, so we have 2 ordered pairs. Here we're only getting 1, so we're only going to have 1 ordered pair. Okay, and I'm going to plug that into the first equation. 1 over x, or 1 over 1, plus 2 over y equals 5. 1 plus 2 over y equals 5. Subtract 1. I've got 2 over y equals 4. I'm going to do the same thing. Multiply both sides by y. And I got 2 is equal to 4y. Divide by 4. And that's equal to 1/2. So y is 1/2. X is 1, Y is 1/2. I'll let you guys do the checking on that. You can just plug these values in and see if they work. All right, number 3, you invested $15,000 in funds that pay 5.25% and 3.5% annual percentage rates. The combined interest from the two funds was $717.50 off of that $15,000. Write and solve a system of equations to find the amount invested at each rate. Okay, well, first of all, just the total principals on both of those, X plus Y, adds up to 15,000. Okay, X we'll call Fund 1 at 5.25%, Y Fund 2 at 3.5%. And then I'm going to take 0.0525 times X. That'll give me the interest that the account X earned, plus 0.035 times Y. That'll give me the interest that Fund 2 is getting. And when I added those, it said that was $717.50. So I'm going to multiply this by, I'm going to get the y's to cancel out, negative 0.035y. You might have chosen the x's. Negative 0.035, not y, forget the y. Negative 0.035x, and then minus 0.035y equals, wrong one, $15,000 times negative 0.035, negative 525. And I'll just rewrite this as 0.0525x plus 0.035y equals $717.50. All right, those cancel. Negative 0.035 plus 0.0525 equals 0.0175 x equals negative 525 plus $717.50, 192.5. I'll divide by 0.0175 here and here. 192.5 divided by 0.0175 is 11,000. So I'm getting X is $11,000. That would leave Y at $4,000 to complete the 15,000. So we will say $11,000 invested at 5.25% and $4,000 invested at 3.5%. Okay. Number 4, it says using the graph of y equals 2 to the power of x, this exponential function as the parent function, write the equation below. 2 to the 0 is 1, 2 to the first is 2, 2 to the second is 4, 2 to the third is 8, 2 to the negative first, that's 1 over 2 to the first, that's 1/2, and then 1/4, and 1/8, and so on. So this is the this is the exponential function here. Y equals 2 to the x. It's obviously been flipped. So it's y equals negative 2 to the x. If I flip y equals negative 2 to the x, it'll be down here. This piece will be right here. This 3 down here is negative 3. I'm flipping it over there. This, no, not 3, 4. 2, 4, 2, negative 4. 3, 8, 3, negative 8. Right here. And then you see, so this is kind of going like this when we flip it. That's what y equals negative 2 to the x. If you'll look, my asymptote is the x-axis. This one you'll look at real close, that asymptote is 3. So we're just taking this graph and raising it 3 units, translating it up 3 units. So I'm going to write y equals negative 2 to the power of x plus 3. All right, y equals 1/2 to the power of x minus 2. I'm going to go x minus 2, and then 1/2 to the x minus 2. Let's put negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. This is negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2. I got way more than I need, I think. Okay, this is 1/2 to the negative 6th. If I were to flip this and make it positive, that's 1/2 to the 6th. That's 2 to the 6th. And that's 2 to the 6th is 64. And this is going to go by halves here. Half of 64, that's 32. 2 to the negative 5th, or 2 to the 5th. 1/2 to the negative 5th is 2 to the 5th. 1/2 to the negative 4th is 2 to the 4th. 1/2 to the negative 3rd is 2 to the 3rd. So that's 8, 4, 2, 1. 1/2, 1/4. So I'm going to make the graph negative 4, 64. No, I'm not using these. I'm going to use negative 3, 32. That's too much. Negative 1, 8. 8. Negative 1, 8. 0, 4. 1, 2. 2, 1. 3/2. 4/4. So this looks like the graph here. And it looks like the x-axis, or y equals 0, is a horizontal asymptote. All right, number 6. $1,000 is invested into an account, and I've got compound interest and then compound interest when it's compounded continuously. I've got these two up here. $1,000, there's your P. For 10 years, there's your T. Here's your R. Compounded semi-annually. That's n equals 2 here. So the amount is equal to $1,000 times 1 plus 0.0475 over 2 to the 2 times 10 power. 1,000 times 1 plus 0.0475 divided by 2, 1.02375 to the 20th power. I'm going to raise that answer to the 20th power and multiply it by 1,000. I get $1,599.11. That's compounded twice a year. Now, if it's compounded continuously, they're figuring out interest more often. Oops. I'm going to use APERT there. A equals 1,000 times E to the R, 0.0475, and then T is 10. And that's 1,000 times E to the 0.475 power. 1,000 times E, that's the second function of this button. So second E to the 0.475 power. That's $1,608.01. Okay, so you get a little more interest. $9 worth. About $1 a year, huh? For compounding continuously with that account. All right, now number 7, rewrite 2 to the 9th equals 512 in logarithmic form. That means the log, here's my log, my base is 2, I'm taking it of 512, and it's equaling 9. And rewriting this, log base 3 of 81 equals 4 in exponential form. So 3 is the base, 4, that answer is the exponent. 3 to the 4th equals 81. Okay, log of 157, round to 3 decimals, 2.196. Okay, this is the natural log in terms of natural log of 4 and natural log of 5. This is the natural log of 5 squared over 4, which is the natural log of 5 squared minus the natural log of 4. The quotient property there is by expanding, and then I'm going to use a power property and wrote 2 times the natural log of 5 minus the natural log of 4. All right, use properties to expand. Multiplying, we'll expand. We're going to write, instead of just one logarithm, we're going to expand so that we write 3. Log base 4 of 5 plus log base 4 of x cubed plus log base 4 of y. And we get the log base 4 of 5 plus, I'm going to put that 3 out front, use that power property. 3 times the log base 4 of x plus log base 4 of y. That was a little sloppy where I put that 4 there. See that now. Okay, I like that answer. Now B, I'm going to write this as the natural log of the square root of 3x minus 5 minus the natural log of 7. And I'm going to use power here. 3x minus 5 is to the half power. Square root is a half power minus natural log of 7. And I'm going to pull the 1/2 there. 1/2 times the natural log of 3x minus 5 minus the natural log of 7. That's where I would like to go with that one. Okay, now this one I copied and pasted and didn't change that word to condense. That's what I meant to do. So I want to get this. Let's write this as just a natural log of x plus 2 squared minus natural log of x. Now let's go in reverse. Subtraction with two different logs is the quotient property. So let's put x plus 2 squared over x. And this one, I'm going to write 1/3. I've got a minus here. So I'm going to write log base 2 of x over x minus 4. Trying to make it smaller. And the 1/3 is can be an exponent here, and I kind of like the idea of changing that to a radical. Log base 2 of the cube root of x over x minus 4. All right, this one we had a lot of questions on. It's easy. Using the change of base. Log of 57 over log of 5. Is the change of base formula. And it's a common log is what I'm using here. Divided by log of 5. 2.512. Approximately 2.512. And if you'll notice, I could have used natural log of 57 divided by natural log of 5, 2.512. Okay, so showing us how, and your answer is important. And I know that a lot of you have the log base. And it was 5 here and 57 here, and this is what you're used to doing. And you get the same thing because change of base formula works. All right. Let's do 14. $5,000 was invested into an account in which interest is compounded continuously. So I wrote that down. After 10 years, okay, this looks like P, this looks like T, the account is worth, this looks like A. What is the interest rate? So what is R? Okay, so let's fill in our stuff here. $5,665.74 equals 5,000 times e to the r times 10. I'm going to divide both sides by 5,000. $5,665.74 divided by 5,000. 1.33148. I think that's all the decimals, so I may as well keep them. 1.33148 is equal to e to the power of 10r. And what I'm going to do is take the natural log of both sides. And when I do, I get 10r here because natural log and e to the power, those are inverse operations. So I'm going to take the natural log of the answer there. And I get 0.12, I'm going to just write that as 0.125. There's so many 9s there after that 4. And divide by 10, I get 0.0125 equals r. And move that decimal over 2 places and call this a 1.25% APR. All right, let's subtract 5 here and here. 3 times the natural log of 2x equals 6. Divide by 3, and you got the natural log of 2x equals 2. And now I'm going to rewrite it into exponential form. Base is e, the exponent is 2, and that equals 2x. Then I'll divide by 2. You can figure out e squared first, and then divide by 2. I'm going to just go second and write e squared. I hit the second in this button if I was going too quick. And then divide that by 2. 3.695. X is approximately 3.695. And just for the heck of it, I'm going to take 5 plus 3 natural log of 2 times 3.695. And I get 11.000, and that's really close to 11. And that is within the rounding tolerance there. All right, you guys take care now.